Welcome and thank you for joining the second session of this series titled Azure Hub Spoke Design, the Art of the Possible. The session will be recorded and available at the URL aka.ms/az networking sessions. At the end of the session, we do ask that you provide feedback at the link provided so that we can keep iterating and tailoring to what our audience would like to see. This is a three-part series, and today's session is the second session of Series 1. Agendas, FAQs, and feedback forms for the sessions, as well as recordings and additional material, can be located at aka.ms/az networking sessions. Future sessions will cover topics including Azure Kubernetes Service, Azure App Services, Express Route Designs, and Azure Firewall. Details of these sessions will be made available close to the time, currently scheduled for summer 2023. For today's agenda, we'll have three topics discussed. Nahali will present Azure Virtual WAN designs, the art of the possible. John from Checkpoint will present vWAN partner integration with Checkpoint, and Maze will walk through a vWAN scenario using tools and technologies mentioned in the previous sessions. Here is the core team developing the content, organizing and producing the series. We have Nahali Niogi, a principal cloud solutions architect supporting Microsoft partners. We have Xavier Elizondo, a senior cloud solutions architect supporting software and digital platform customers. David O'Keefe, a senior partner technology strategist. Sean Croucher, a senior consultant working with the UK public sector. Heather C., a principal cloud solutions architect focusing on Azure security. And finally, myself, Matthew Betts, a principal cloud solutions architect working with financial services customers, focusing on Azure core technologies, including Azure networking. We would like to say a huge thank you to our moderators who are monitoring the Q&A, ready to answer your questions throughout the session. As previously mentioned, the recording and any links provided throughout the session will be available at aka.ms/az networking sessions. For today's sessions, here are your presenters. We have Nahali Niogi from Microsoft. We have John Go from Checkpoint, and we have Maze Al-Jabari from Microsoft as well. Nahali, if you're ready.
I'm ready, Matt. Thank you. Hi, everyone. Let me just share my screen. Hi, everyone. Thank you again for joining. I see a lot of familiar names in the audience. And for those of you who don't know me, I'm Nahali. I'm a cloud architect, and I work with the partner ecosystem. And prior to joining Microsoft, I have experience working with service providers in data center networking and security team. So welcome again, and thank you to our moderators and presenters for working behind the scenes to support this live event. As I mentioned last time, as you join on this journey of networking sessions with me, imagine yourself as a cloud architect running these exact envisioning sessions with your potential customers or cross-functional teams for that matter, right? Using this approach of diagramming and storytelling with layers. It's again, the art of the possible, and more importantly, understanding the why behind the networking design options, right? And lastly, keep a growth mindset. Today, we're going to be showing you some features that are in private preview. We want to caution you that while we don't recommend those for production workloads, the idea is that we learn and grow together, all right? And I'd love to hear about your scenarios. And if you are a partner and would like to present in the future sessions, do reach out. We still have some open slots. So on my screen, what you are seeing is a global transit network architecture using Azure Virtual WAN. In the last week's session, we did Azure Hub and Spoke design. This is also a hub and spoke architecture, the main difference being that the central hub that you see is a managed service. It brings some of the routing and security services together. Of course, the scale and performance numbers are different. So do check it out on our limits documentation. So in this session, we'll go over a lot of the common design patterns and scenarios. So let's get started. So first, I'll get you familiar with my screen because you're going to be looking at it um, for a, for the next half hour or so. So let me get you familiar with my screen. So what you see in the top left-hand corner over here is that draw.io is integrated with VS Code. Of course, I also have Git integrated. So when I update these diagrams, I can check it directly into GitHub. And then I have layers over here. We will go into a lot of depth with layers, but for now, I just want to show you that there are a lot of pre-created layers. Then there is in the center, you see this vWAN, vHub, and then the two spokes. So that's on the Azure side. On the bottom, you see your on-prem sites. It's a hybrid connectivity architecture. So bottom is all private connectivity. You also see a few tabs over here. Today we'll cover the first few tabs. So vWAN, and then we'll go into some details of multi-region as well. All right. So with that, let me before we dive into the layers, I want to do a short demo of Draw.io. So you can follow along with me how these layers are created. So I'm going to bring another screen here. You can see the screen. So again, in the interest of time, I have pre-staged the hub and spoke architecture on the left-hand side. Now, I have a detailed YouTube video that shows you how to get here on the left side, and it's on my YouTube channel. So do be sure to check it out. The main goal of this demo is to demonstrate layers, and you will notice that my screen is slightly different from the presentation last week. What you are seeing has a lot more real estate, and what it is a Draw.io app that's also available in the Microsoft Marketplace, and the feature that we're using is called Draw.io board, and it's very similar to whiteboard. I use this board while running sessions with customers that bring in, for example, their own design. I want to annotate on top, to drive more engagement and collaboration. So that's the use case for this board. It's still Draw.io under the hood. So let me show you a quick demo of how the layers are created. And before that, I'll give you a quick actually overview of the different parts of this screen so you can follow along with me. So here you would see that there is a little pane for bringing in shapes and objects, and you can even hide it. So I really like how you can collapse and get so much real estate on your whiteboard. And then this on the top is a menu that you can pull in layers and other things. And at the bottom, you can also get tabs if you needed to. And notice I brought in an image over here. So for example, this could be your customer's architecture that you want to talk about, but I just brought in a sample image so you get the idea. All right, so I'm ready to demonstrate layers. So what we can do, let's move this on the side a little bit. What we could do is let's bring in the layers pane. Oh, and I forgot to mention that the way you could bring this whiteboard is using this theme called Sketch. The Sketch gives you that whiteboard look and feel in draw.io. All right, so let me bring up the layers pane. And again, I'm going to do a little, I'm going to show you what to look for as I move around my mouse. So in this layers panel, there are the 3 ellipses right here, and then there is a plus sign over here. I'm doing this demo again because we have almost doubled our registration from last session. So just to keep everyone kind of follow along with me for the rest of the session. So let's add a few layers here, 1, 2, and 3. As you can see, they show up as untitled layers. So we'll call this hub spoke. We'll call this branches. And we'll call this flows. All right, and now how do we move these this architecture into layers? It's very easy. You select the objects of interest, and then you go to these ellipses, and then you move it to hub spoke. You select these branches, and then you click on this ellipses, move them to branches. And then you can control click and select these individual flows, and then you can move them to the flows layer. And now let's see if the layers work. So we turn off the flows, we turn off the branches, we turn off the hub and spoke. There we have, let's bring it back up again. And there we have a fully layered hub and spoke architecture that we just did in minutes. All right. And then a lot of you have asked me about this flow animation. So I'll just take a minute to show you how that is done. So let me bring this format panel over here. And the way the flow animation is done is if you highlight the flow, there is a property, if I can get that here. There is a property called flow animation. So if I uncheck that, the flow stops, and then you can animate the flow. All right. So I'm now going to go back to my the main part of the presentation, and now that we know how these layers are created, you can follow along with me. All right, so let me move this out of the way. So here I would close this Explorer so we get more real estate. And then again, I want to show you how these layers are created in the actual So here you would see that I have what I called a base layer. The base layer would always stay on. Notice the little eye icon. When the eye is open, that means the layer is lit up. And hence the rest of the layers you see really grayed out, but I'll walk you through what it looks like. So once the base layer is lit up, I have various other scenarios that lay on top of the base layer. So this is scenario 1, 2, 3, and so on. All right. And as we progress along, I will light up the layers, and then we can walk through various design patterns and various scenarios. So let's get started with our first layer. So I'll light up another base layer, which is also which is the second region. And then we will light up the rest of the layers as we progress in this. So all of the base layers are lit up. There is an optional base layer called IPs. Like I mentioned before, there is no networking discussion without IPs, right? So I like to put IPs sometimes for my labs, sometimes for conversations with the customers. So for most part of this, we would turn this off to keep it uncluttered. So let's look at scenario number 1. And so now the way we will approach this whole session is we will talk about flows. And by flows, I mean IP connectivity. So let's focus on the default flows. So as you can see with this green lines, what these green lines are showing you is IP connectivity. And what that means is from spoke 1, you can talk to branch, a site-to-site connected branch. The first two, of course, are site-to-site connected, and then these two are express route connected branches. So it is showing you that you can talk from spoke to a site-to-site connected branch. Similarly, the pink box is a point-to-site client, a client VPN, client, what we call client VPN. So all of these green flows are working flows. They provide you IP connectivity. Same way, let's light up the region 2 flows. I'll make it a little bit smaller so we can see everything at the same time. So now we are seeing that within the same region, you are getting all of the working flows. So now let's look at inter-region. By what I mean is this is region 1 and this is region 2. So let's look at the inter-hub flows. So I light up inter-hub flows. And sometimes if you just want to focus on the flows of interest, you can uncheck the other ones. So that's what I did. For now, we'll look at inter-hub flows. Now there is a lot to see, but they're all color coded. So follow along with me. And sometimes you will see in our documentation or our Microsoft architects talking about VHHV or something that's really short. So what that means is that this flow is going from a VNet to a hub to another hub to a VNet, right? So this orange flow is that flow. And again, unless I mark a flow as red, that means you have IP connectivity. Again, we haven't added the firewall layer yet. This is strictly, we're talking IP routing, IP connectivity. And then this pink flow, of course, is showing a spoke on one region talking to a branch on another region, right? And then this blue flow, very, very powerful construct. A branch on one end is talking to branch in another region, branch in one region talking to the branch in another region. Essentially, you are getting IP routing between your branches through our Azure backbone. So that's where this is very, very powerful. And then, of course, the green flow is the one express route to express route always goes through global reach. All right, so that's and so if I light up everything, right? So let's just look at everything together. So you could see the as a service part of this design, that you are getting full any-to-any connectivity as part of this design. Now, if you want to get exactly what I'm showing in this diagram in one click, Mark, our global black belt from our UK office, has done a fantastic lab or a hack with various challenges explaining the concepts and the why, each flow works certain way and how you can light up all of these flows. So be sure to check it out. There is a link in the FAQ if you want to do it. And again, thank you, Mark, for doing such a wonderful lab for everyone. So with that, I'm going to turn off scenario number 1 so that we can look at the second pattern. So let's light up scenario number 2. Now, what drives the need for scenario number 2? As you can see, we got a little firewall icon in both of the region. So scenario number 2 is about bringing firewall capabilities into the vHub, and we call it secured vWAN hub. So as you follow along with this with me, you will notice that there are quite a few flows. To keep focused, I have divided them first into north-south. So let's look at north-south first. And the terminology north-south in this diagram really means that the egress from this site, right? So and any express route connected site or any branch reaching the internet through the firewall in Azure. Okay, and again, a couple people asked me about this, but this AVS site is just a representation. For all practical purposes, this could be any express route connected branch. All right, so let's look at how this is working. Now, there are two important things to observe over here. You could see that we are advertising the 0/0 or the quad 0 route down this way. And you could also do that if this is an express route connect IPsec BGP over IPsec. If you're running, you can advertise it down that way as well. And what that does, it drives this flow. All right, and of course you can also have spoke reaching the internet through this firewall in the hub. Of course, you cannot advertise quad 0 this way. And same thing with region 2, right? So now that we know north-south, let's look at east-west. Because there are a lot of flows to see, I've divided them into layers so we can look at them individually. Now, here, what you are seeing, and best is to focus on one region when we are doing this. So we'll focus on this region, okay? So you can follow along with me. Here, what you are seeing is that when we brought this firewall in the secured vWAN hub, the green flows are traversing the firewall, right? So you get the firewalling capabilities with that. However, the branch to branch is still bypassing the firewall. So it's important to know the difference there. Now let's look at inter-hub, right? So we'll look at inter-hub connectivity. So again, at this point, I will caution you, we are going into level 300 of Azure networking. What you are seeing here is that a spoke in one region cannot talk to spoke in another region. The reason being, and of course, this is a scenario with the secured vWAN hub. The reason being that the traffic gets asymmetric. The dashed line is showing you the traffic going from this spoke to this spoke, and the dotted line is the return traffic. As you can see, the return traffic gets asymmetric, that this traffic bypasses, the first flow bypasses it, and the return traffic gets asymmetric, so that flow breaks. Now, how do we solve? What are our options in this scenario? Let's look at the next layer. I put a little light bulb over here to give you ideas on what you can do. Again, this as an architect, I would call this in an increasing order of best practice, or you optimal design. That's the right term I was looking for. So today I would, if routing intent feature is not available, but if it is designed to solve that flow, it's still in public preview for single region only, then we have a tiered VNet design, and I'll show you exactly how to do that using a tiered VNet design. And then the third option that we have, and I would call it a workaround, is using the express route bow tie design, which I will cover in the multi-region. And you can get that spoke to spoke flow through the express route bow tie design. Again, like I said, this is please look at the preview option and use it with caution, that it is not recommended for production workloads. So with that, let me take a quick look at the notes here. Again, if you are a presenter and if you're using these, be sure to check these notes. They have, a presenter's notes in case you need to review them. Now let's move to scenario number 3. Let's look at what drives the need for number 3. So I put a requirement over here, right? So if you have a third-party firewall like a Cisco or a Palo or a Checkpoint, a third-party SD-WAN appliance, that's where this design is used. So now, and it also solves some of the routing scenarios. So let's look at this feature called BGP endpoint. So in the vWAN, we have similar to what we did last week with Azure Route Server. In vWAN, we have a hub router, and you can peer your NVA with the hub router using eBGP peering, and then you can advertise the quad 0 route, which kind of goes down this way as well, just very similar to the Azure firewall. And then what that gives you, and this is the use case for this design, is it gives you this north-south flows. So north-south, again, north-south in this session means that the traffic that's egressing to the from our sites, branches, or our spokes to the internet. Okay, so this pink flow is north-south. And again, I only show one site, but it's applicable to all of the sites. All right. So that's our north-south flows. You can also light up this optional IP. Sometimes I use this diagrams as my own notes. So notice I have ran a curl command and it shows me the IP of this firewall when it reaches the internet. I'm running ifconfig.me. Same thing if I'm a point to site client, I get the IP of this firewall, right? So sometimes I light up these layers just as a note to myself, or just, just to see where my lab was at any given time, a state of my lab. Now, another use case for this BGP endpoint or the scenario 3 is, let's say that you have this NVA hanging off of an NVA subnet, and this NVA could be an SD-WAN appliance, right? So in other words, let's say you didn't have this, or you could have both together as well. But let's say that you did that your SD-WAN was hanging off of this cloud was hanging off of this firewall. In that case, you can, similar to the quad 0 advertisement, let's say you had a 172.18 network for your SD-WAN, you can advertise those down this way, and that drives this green flows. Yeah, this green flow. So from an express route connected branch, you can reach an SD-WAN connected branch. This was a scenario I worked with an AVS customer. So kind of corner that I've documented this as well over here. Now let's see what happens to the east-west flows in this design. Again, I do north-south, east-west, and then inter-hub just to keep things organized. So east-west, this goes into level 3 to 400. All right. So east-west, let's look at this green flow. So if you want to steer traffic from the spokes to the branches through the NVA, it is possible. There is, if you have this diagram and if you click on it, I have created a link to the precise documentation that shows you exactly how to do it. It does require custom route table, but you can achieve this flow. Again, this is the art of the possible. Mark's lab goes into very deep detail of custom route tables. So be sure to check that out. But for you to achieve this flow, you need to use the custom route table. All right. Now let's look at the pink flow. With this NVA design, the pink flow will bypass the NVA. All right. And then similarly, the blue flow will, meaning from branch to HQ or branch to an express route connected branch, a site to site to an express route connected branch will also bypass the NVA, and it applies to all of these branches. Okay, so again, the use case for this NVA, a very common use case is, like I mentioned, SD-WAN and NVA. So be sure to know what your requirements are and what the use cases are. So we did the east-west. Now let's look at inter-hub. So how does the inter-hub flow look like? Oh, and this is a good time for me to show you this really nice feature called outline in Draw.io. So as your diagram gets a little bit bigger, you could use this kind of outline for you to kind of get to the right place in your diagram. Okay, so I'll turn this off for now, but all right, so inter-hub, you could see that inter-hub also, so let's look at the orange flow, also bypasses this NVA. And similarly, this blue flow, which is branch to branch, also bypasses the NVA. All right. Now let me make sure that I'll take a quick look at the notes to make sure I haven't missed anything here. All right. Yes, so now let's look at some of the routing considerations. So if you want the spoke to spoke, so if we looked at the east-west before, if you looked at the east-west before, you saw this pink flow. We could not steer it through the NVA. So that's what this one is showing. So let me light that up again. So if you want your spoke to spoke to go through, to traverse the NVA, this is, you cannot achieve it with this design. Again, anything red in my in the flows would indicate that that flow will not work. So what are our options? Let's look at the next layer. So our option here is that we use what we call a tiered VNet or an indirect spoke. So I think our documentation calls it indirect spoke design. In other words, you have an NVA VNet, which is hanging off of the main vWAN hub, and then you have spokes that are connected as indirect spokes. So that's what this terminology means, right? And then you can achieve this green flow, which before you couldn't achieve. So you really have to move your spokes here to achieve that. Of course, my colleague from Checkpoint, John, he's going to go over a lot of fantastic scenarios with partner integration. So that's definitely coming up next. But I did want to show you the tiered VNet design. So now let's look at how the rest of the flows work in this tiered VNet design. So here, let's light up the next layer, which shows the branch flows. So even your branch can now be steered through the NVA. Again, you will notice that I don't have the BGP peering. You can do it either with or without the BGP endpoint. In this particular design, you could put static routes in the hub default route table. all right, to achieve this. But you could also do it with BGP peering. And then you have this flow, which interhub. See, before interhub was bypassing the firewall. Now the interhub will traverse through one of the NVA. So in this design, it will traverse this NVA. Of course, if you were to do it from here to this way, it would traverse the other NVA. All right, so that's in the other direction. And then the last layer here is spoke to spoke. So let me make it a little bit smaller so we can see the whole thing. So this one is the pink flow between this tiered or indirect spoke to another indirect spoke. This is the pink flow, which is going through firewalls on both ends. So quick time check here for myself. All right, so we have I have one more scenario in this in this single region. Even though we're seeing multi-region, I use the term single region because we're not using the express route bow tie design yet. So this is the new routing intent feature. Again, this is in public preview, single region only. So let's look at what this feature brings to the table. Here we looked at internet traffic, and then we have it gives you the it gives you all of the branches, the capability to egress from Azure, and also traverse the firewall. And same way, all traffic, private traffic, would also traverse the firewall, which in the other designs, some of these flows were bypassing the firewall, right? So that's the key differentiator here, is that everything. So if you look at the use case for this, it says private and internet traffic via the firewall. Quite powerful. Again, it's not available, and it's only currently available in single region, and you cannot turn on both private and internet at the same time currently. But again, we're sharing something that is still in preview. And then lastly, I want to show you the inner hub. Again, today this is only available region 1, both same region, but quite powerful. It goes through all of these flows, go through the firewall both ways. So this purple flow is spoke to spoke. Blue is branch to branch, quite powerful through the firewall. And then green one going from site, one site in one region to spoke in another region. With that, I have a few more minutes and I will cover multi-region. So in a multi-region design, this is a classic bow tie or crisscross design, this being the cross over here. And basically, you're providing redundant connections for hybrid connectivity. So this site would have redundant connections to both of this region. Of course, in this design, we're showing express route, but if you are running VPN, BGP over IPsec, you can do that crisscross design the same way. And we also have express route with VPN failover. So I have an optional layer of ASN in case you're having conversations with customers. And then I have inter-hub flow. Notice how the inter-hub flows are going, are hairpinning through the MSEEs. All right, and the dotted line, sometimes the return traffic can also traverse the other leg. So just be aware of that. And lastly, I want to show you how you can leverage the inter-hub connectivity instead of hairpinning through the MSEE. And that's done using the feature called hub routing preference. And I have a screen capture of that here. How you could change the hub routing preference. And the last scenario I want to cover here is, remember how I mentioned that we have a workaround for this scenario, that when your spoke-to-spoke traffic gets asymmetric, that's how you can achieve this. So this flow, the one that hairpins through the MSEE, gives you that workaround. Of course, you want to be aware of the extra latency, and of course you are burdening the express route gateways with this design as well. And lastly, I just want to say thank you to everyone for joining and listening. And again, your feedback is really important to us, so do let us know. And over to you, John.
Hi, Nahali. Thank you so much for the opportunity. So give me a second. Let's go ahead and share my screen here. I hope everyone can hear me okay.
Yep. Yes, we can.
Okay,
We can hear
excellent. You. Okay, great. Okay, so I am sharing my screen now. Let me know if you guys can see my screen, and I'll start.
We can, John.
Okay, awesome. Okay, awesome. Good morning. My name is John. I am a Cloud Alliance Architect from Checkpoint. I've been with Checkpoint for almost 10 years now, and the last 3 years been working with integrations with Microsoft. I'm based out of Redmond, Washington, father of 2 daughters. My 12-year-old starting to give me heartburn, so I occasionally turn to Call of Duty to relieve those symptoms. Now, I'm going to spend the next few minutes today to give everyone a quick overview of how third-party security partners such as Checkpoint can help secure Azure vWAN. For those that are not familiar with Checkpoint, we're a pure-play security company providing security solutions for cloud, network, and endpoint. We're based out of Israel, and it's a long-time Microsoft partner. Over the next few minutes, I'm going to share 2 reference designs using the templates that Nahali created, and how Checkpoint can help secure Azure vWAN. All right, so the first integration I want to highlight here is our Harmony Connect. In fact, this is the solution we're a launch partner with Azure vWAN back in 2019. The problem that we're trying to solve was to provide egress to internet protection for vWAN connected devices like VNet, branch offices, etc. Harmony Connect is our SASE and ZTNA solution. And at the core of Harmony Connect is our Checkpoint firewall. So think of Harmony Connect as our firewall as a service. Now, how it works is it's fairly straightforward. Customers deploy Harmony Connect with the Azure Firewall Manager. After the deployment, all internet-bound traffic from vWAN will be secured by Harmony Connect. Now, one of the main challenges with firewall as a service is latency. We solved that problem by deploying our workloads in the same Azure region as customers' vWAN hubs. Now, the advantages of running Harmony Connect is customer has a centralized choke point now, right? Because all internet traffic from vWAN will go through Harmony Connect. Having that centralized choke point will allow customers to apply those advanced threat prevention capabilities. Now, since Harmony Connect is a firewall as a service, all customer has to do is to define their security policy and never have to worry about upgrades or scaling out. Checkpoint would help our customers take care of all of that. To enable Harmony Connect from Azure vWAN Hub, you go to the Firewall Manager. And from Firewall Manager, you see the vWAN security partners, such as we also have other partners here like Zscalers and iBoss. So you obviously select Checkpoint. Next, your service principal, enter your service principal and your subscription details in the Checkpoint Infinity portal, and that's it. You know, from there you can start defining your security policy for all your to secure your vWAN services. Couple considerations here with this particular design, and Nahali touched base on this earlier, is that with this particular service, we don't have the capability to provide the east-west traffic inspection, right? So for example, traffic between VNet branch offices or point-to-site VPN clients are connected to vWAN. There's no way for Harmony Connect to inspect that traffic. You know, this creates a gap, especially for you know, for heavy compliance industries such as, you know, FSI, healthcare, and utility companies. Now, this brings us to our second design, which is we'll leverage the new routing intent feature, right? Let me highlight that here. Okay, so this design will leverage the routing intent feature that is currently in gated public preview. So Holly also highlight this as well. We're actually in preview. So if you're interested to participate, Checkpoint is accepting new EA and preview customers. So feel free to reach out if you're interested in testing this feature out. Now, the problem that we're solving here is to provide a full east-west traffic inspection between all connected resources in vWAN. The solution really consists of two main components. Number one, we'll be installing the Checkpoint CloudGuard Network Security Gateways inside the vWAN hub. CloudGuard Network Security is Checkpoint's IS solution. It's not a service like our Harmony Connect solution. Second is we'll need to leverage the new routing intent feature to allow the traffic to be inspected by Checkpoint. How it works, right? For example, if I want to protect internet-bound traffic, I will enable the routing intent for internet. And what will happen is that vWAN will route all internet traffic to CloudGuard Network Security inside the vWAN hub before it goes out to the internet. Second, to protect east-west traffic, I will enable the routing intent for private traffic. This diagram is really, really great here. So once I enable the private traffic, all the flows between the branch offices or point-to-site client or HQ or different, even with different express routes, right? Let's say you have two different express routes, traffic between the two express routes, when it hits the hub, that will get routed to CloudGuard Network Security for inspection. And obviously any spoke VNets between spoke 1 to spoke 2, that will also get inspected as well. So now we can do a full east-west traffic inspection, right? So that's the main advantage of having the routing intent. The other advantage is any new connection to vWAN is automatically protected by CloudGuard as well. So let's say if you have you provision additional spoke 3, 4, 5, that traffic will automatically get routed to the checkpoint for inspection. So customers really don't have to manage the different UDRs and static routes, right? With different with the previous architecture and how they mentioned. Routing intent also allows the inter-hub traffic inspection, right? Again, within the same region, right? Inter-hub. So let me give you an example here. So some customers will be deploying the SD-WAN solution inside the hub. So there are third-party SD-WAN appliances such as Checkpoint, like Barracuda, Cisco, VMware, Versa, Aruba, and Fortinet. Traffic that are connected to the third-party SD-WAN appliances, when they connect, let's say branch 5 and 6 and spoke 3 needs to connect to the security hub with CloudGuard Network Security installed. Any resources connected here will be inspected by Checkpoint coming from branch 5, 6, and spoke 3. Now, there are a couple of caveats I want to highlight here. Number one is traffic between spoke 3 to branch 5 and 6, that traffic will not be inspected by CloudGuard because that traffic will traverse through the SD-WAN hub. That's number one. Number two, because the inter-hub does not advertise the quad 0, right? So there's no way to redirect traffic from the SD-WAN hub over to the security hub with CloudGuard installed, so to inspect traffic to the internet. So as you see this link here to the internet, so traffic from this hub will go out directly to the internet without going through Checkpoint. Couple questions that came up is that why do we have to install two different hubs? Can we install the SD-WAN and the Checkpoint security gateways in the same hub? That is currently not possible. Because you allow, the vWAN hub only allowed to install one third-party vendor right now. So that's why we have the two-hub design. That being said, traffic can be protected, right? If you have multiple branch offices and you need to connect to resources in Azure with your third-party SD-WAN appliance, that traffic can be inspected by Checkpoint now. Lastly, I want to highlight ingress scenario. Okay, so with the ingress scenario, we need to deploy a separate VNet with CloudGuard Network Security installed inside, right? So this is an ingress subnet that is also peered to the vWAN hub. And this is the use case here is for customers that want to publish the applications to the internet, leveraging the external load balancer, have multiple public IP addresses assigned to it so that you can publish, different apps to the internet. You will need to deploy a separate VNet with Checkpoint or obviously with other security partner as well, you can actually do that with a separate VLAN. In terms of deployment, customers can find our solution from the Azure Marketplace. So we already published our CloudGuard Managed vWAN in the Azure Marketplace, so you can start deploying it now. However, you still need to get your subscription whitelisted before routing intent feature can be enabled for your subscription. But you can, once that is done, you can deploy our security solution. And as part of that, we also have a how-to video, how to deploy the solution step by step, including how to enable routing intent here. As part of the managed application, we'll also be publishing the throughput from. One second, see if I can zoom in here. We'll also be publishing our throughput with the different scale units to make it easier for our customers to select the right throughput requirement for their vWAN deployment. And lastly, this is what the routing intent feature looks like. In this is a really nice feature because customers can deploy the two-tier firewall design if they want to, right? So I've been in the security industry for like 20 years, and I've seen there's some customers like to separate the internet-bound traffic firewall with the internal firewall. So you can do that by installing multiple versions of the CloudGuard Network Security gateways, and you select the version 1 for internet and version 2 for east-west traffic for your private traffic. This is also very useful as well for upgrade process as well. So if you want to upgrade your CloudGuard Network Security gateway, you can install a new version, right? And then you can switch back and forth between the two different CloudGuard versions. Couple considerations I want to highlight is in terms of site-to-site VPN traffic, CloudGuard cannot support that just yet. We recommend our customers to deploy any site-to-site connectivity into vWAN via the Azure VPN gateway. We do support point-to-site VPN into the CloudGuards or client-to-site VPN into the CloudGuard security gateways, or alternatively, you can of course use the Azure point-to-site VPN gateway there as well. Now, as a result of this integration, we now have a very clean and simple network topology, which makes designing and scaling Azure very easy for our customers. And we're super excited about this integration, and we hope this integration will go GA in the near future. So with that, thank you so much for your time. I'm going to pass this presentation to the next speaker, Maeve.
Thank you, John. Thank you, Nihali. Hello, all. Thanks for joining this session. My name is Maeve Al-Jubari, and I'm part of Global Black Belt team, and we are specialized in advanced Azure networking. I help customers with complex networking solutions, provide best practices as well for hybrid cloud connectivity and for Azure networking. So I'll share my screen, and today I'm presenting one of the use cases for the virtual WAN, where it has simplified and resolved one of the scenarios for our customers. And I just want to check before I go ahead if you guys see my screen.
We do indeed, Maze.
Okay, thank you. And as you can see, I'm using the oldest schooling with whiteboard. I'm still learning using Draw.io, but I didn't want to torture you in my learning journey. So I will just use the whiteboard today. So the use case I will talk about today is how to connect two branches. Let's say here in the picture, I'm showing London and San Francisco, and we call this a branch in terms of express route. How to connect two branches using two different express route circuits privately when utilizing Microsoft backbone network, right? Today, we give this feature to in specific regions by utilizing what we call the global reach. So what the global reach is doing is just like you link two circuits that are in the regions that are allowing to do a global reach. And once that is done, you can have a private connectivity between your two branches here. Now, maybe this is not something interesting to many customers, like, okay, I'm not really interested in routing my traffic over Microsoft backbone. But this is comes significant when we are talking about some bare metal solutions hosted in Azure, where we provide private connectivity to them by using dedicated circuit. One of these solutions is, let's say, Azure VMware solution that's hosted in our data centers, and we give a dedicated ER circuit for private connectivity. And also the same concept will apply to other workload solutions like SAP, high performance compute, HPC, or sometimes also for the OCI. Azure Cloud, Oracle Cloud Interconnect. So how we are solving this today, how we connect, right, privately, let's say the AVS with on-prem. Let's say on-prem is also utilizing an ER, right? So how can I connect these two and have the private connectivity going between these two branches, even that global reach is actually not supported in Brazil? Because Brazil is one of the regions where we don't support a global reach. So today, how we solve this with hub, let's say hub and a spoke environment. I'm not showing a spoke here. I'm just like the model. This model is representing a hub and a spoke. The hub is just a virtual network. In order to have this private connectivity, what we can do is we utilize an Azure route server. And as mentioned by Nihali, it's like something similar to a route reflector. And whenever you use an Azure route server, and if you want to introduce or to inject specific route, you will have to use an MVA. So you will need a third-party MVA that supports BGP. You attract the traffic up to Azure to either do inspection. Let's say one of the use cases also, not only for sometimes when global reach is not there, you want maybe global reach is available in your regions, but you still need to have inspection in Azure and then back to on-prem, let's say. So you will have an MVA that's doing inspection. What this MVA will do, will attract the traffic up here by playing with routing. For example, let's say on-prem is 10.154, AVS is 10.12. What you can do is you can advertise by this MVA a supernet prefix that will attract the traffic up here. This MVA will send to the ARS through eBGP. ARS will send it down to the ER gateway. ER gateway will send it to both ER circuits. What's going to happen is AVS, anything it doesn't know outside of 112, it will send it out here, right? Same thing to the on-prem, will send it up here. Now, in order to make this traffic, when it comes to Azure, it doesn't go this way, because with this, just advertising 10/8 using the MVA, that will attract the traffic up here. But that means the ER gateway will say, oh, okay, you want to communicate with the on-prem 10.154. I have more specific route. Let me just go down here. So the traffic will be going this way, which is not recommended at all, because the ER gateway is not designed to route traffic between on-premises, and you will quickly hit some ER gateway performance limits. So it's not recommended at all. So what we can do to attract the traffic actually up to Azure, to the MVA, also in case you also want to do inspection, not only routing, right? We have to have a UDR on the gateway subnet with a specific on-prem and AVS prefixes saying, hey, actually, if you want to go to on-prem, let's say here, go to the next hub, the MVA. So I force the traffic when it comes here to go to the MVA, and then MVA will send it back to the ER on on-prem and vice versa. Now, this is a solution that's true. However, you see that we have to use a UDR on the gateway subnet. And today in my example, I'm just having one prefix. What if on-prem has multiple prefixes, right? That means I will have to define them all in the UDR. And this is not really a scalable design because you have to manually manage this. Plus, if you want to utilize a fast path, which is fast path is when we bypass the gateway in the way in to Azure, because today, when the traffic comes in through ER, it comes to the MSCE, our edge router, then it goes to the gateway, then it goes to the, let's say, destination, which is here, let's say the MVA. Return the traffic, go direct to the MSCE. So if we want to do fast path, we will also bypass the gateway here, and we just go direct to the MVA. If you want to enable that fast path, right, UDR will not be honored in a service provider model. So that's one of the down, or let's say not down, but one of the, let's say, cons when using this solution with just normal VNet or normal hub. Now, this is one thing, let's say, and here we are assuming we're all in the same region. Let's say all of this is in Brazil, right? What if I have two regions? What if my AVS is in Brazil while I want to access something in on-premise that is in South Central, for example, let's say? In that case, I will not have that UDR thing, because what's happening is this MVA here will advertise the Azure VMware Solution prefixes down to the other MVA by utilizing eBGP and an overlay. And I will say why we are doing overlay here. So we are going to have eBGP here and also eBGP between the route server and the MVA. So these routes get advertised to the MVA down to this one, then to the route server, then to on-premises, same thing the other side. This solution will need, again, NVA, route server, and eBGP connection here, and an overlay. The overlay is required in order to avoid any looping that can happen, because when this route server, let's say, learning the route for on-prem network, right, it will inject it with the next hub as this MVA, because this is the last hub it's paired with. This will cause a loop at the MVA here. Like the MVA say, okay, I want to go to the on-premise network, but it sees itself again as a next hub, while the next hub should be actually this MVA, right? Once you utilize an overlay solution here, either IPsec or VXLAN, that's not going to be an issue because the operating system will take care of it and just send it to the right MVA. So what does that imply? That means I will have some bandwidth limitations here, because every overlay solution, let's say software-based IPsec, or let's say software-based tunnels, will be capped for a bandwidth of, let's say, around approximately 1.5 gigs. So you either have to accept this limitation or not accept. Let's say if your application is fine with 1.5, which is I doubt, or you have to manage multiple tunnels in here between the MVAs, right? So this is let's say, one of the things that comes with this design. Now, coming to the new feature with the virtual WAN, with a secure hub that's called routing inter-routing policy, as mentioned by Nihali, that's today is in public preview for one single region. How can we achieve this private connectivity between those two circuits when there is no global reach, right? What routing inter-routing policy is doing, once you enable secure hub using this feature, it will push down RFC 1918 to each side. This will attract the traffic up to Azure, get inspected, and passed down here or the other side. No UDR needed on the gateway to steer the traffic. This will be taken care of for you by default, because once you enable this, you will see a UDR already injected here with the next hub as Azure Firewall for any RFC 1918 prefixes. Also, no IPsec or overlay included, so you can use the whole bandwidth you want through your circuits. This, as I mentioned, this is still in public preview. And today, by default, we push RFC 1918. When this is becoming GA soon, this behavior will change. We don't send this by default. This will be optional to the customer to say, hey, actually, I want you guys to send me RFC 1918. So it's not going to be sent by default. With, let's say, multi-region with a secure hub, that also can be possible. Before, we cannot have a branch-to-branch inspection. Today, with the routing internet policy, we'll have branch to branch even in single hop, because before routing internet policy, there is no way, even if this is a VPN, let's say this is VPN and this is ER, you still cannot have branch to branch inspected. With a multi-region, the same point. This one will push in RFC 1918. AVS comes to Azure, traffic sent to this firewall, from this firewall down here, and same thing on the return path. So this is at least this, because this is a public preview, have been used by many customers just to resolve this global reach limitation, mainly in Brazil, let's say, one of the regions. And it's really helping customers to utilize Azure as from bandwidth perspective and easier routing configuration for them than the other two solutions I presented earlier with the normal hub. I hope this is all what I want to present today. I hope this has been informative, and thank you all for joining. Back to you, Matthew.
Maze, thank you very much for that. I'd like to say thank you everybody for attending today. We've posted in the chat the link to the feedback form. So please do leave us feedback. We will use that to drive future sessions, and looking forward to presenting again next Thursday.